And now for the last part of this chapter, the valuation of options and how they change the determination of a project. So the two that we're going to talk about is, what if you had an option to delay or an option to abandon? Up till now, we've just been talking about, do you do the project or do you not do the project? So it's a binary decision, but now you can have different scenarios. So the first scenario is one where we are told that you can go ahead and buy a machine today, and they give us a table of information. They've already calculated the answer for us, but really this is what we're supposed to calculate. So let's look at it this way. If you did it at time 0, the cost of the machine is $20,000. The present value of all the future cash flows is 25. So then the net present value at time t, which is time 0, would be 5,000. The cash inflow minus the 20,000. And if we convert it to time 0, it stays at 5,000. So you would go ahead and do the project today. Now, what if this machine becomes cheaper next year and it's going to be 18,000, and it'll still generate the same 25,000 over the life of this machine? Would it make sense to delay it? Well, the NPV at time t would be the 25,000 minus the 18, so it'd be $7,000. This is in year 1. So if we convert that into year 0, what's the value of 7,000 a year from today? It's going to be $7,000 divided by 1.1 to the power of 1. Okay, so it'll be 6,364. So you would wait a year because it went up from 5,000 to 63,464. And if it keeps going down, in year 2 it goes to 17,1, and we run the same scenario again. You can see the NPV now is 7,900, and in today's dollar values it becomes 65.29. Okay, so that would be the 7,900 divided by 1.1 to the power of 1. And it keeps going down again in the future, but it's not going down as much anymore. And the time value of money is eroding the NPV. So you can see that it goes up for the first 3 years, and then it starts to decline. So the optimal time to do this is you would do the project in year 2. And what's the value of this option? So the value of the option is equal to the new NPV, which is the NPV with the option, minus the original NPV. Okay, and the new NPV was 6,529. And the original one, if we did not have the option, we just had to do it today, it was 5,000. So the value of this option is 1,529. Okay, so each option would have some value. Now let's look at one where it's an option to abandon. So we're going to look at a scenario where the company has a machine that they can buy for $300 today. And there's 2 possible scenarios. Both are equally likely. The NPV of the scenario will be 1 year from now. So in the future, we'll find out if it turns out to be successful, it'll have a positive NPV of 575. If it's a failure, it'll have 0 as an NPV. And the discount rate is 10%. Should you do this project? So should you do the project, we'll look at the expected NPV in this case. It's going to be the negative $300 that we pay to buy the machine, plus there's a 50% chance that we have an NPV of 575, and there's a 50% chance that we have an NPV of 0. But we're going to discount it back because that's 1 year from today. So our NPV is negative 38.64, our expected NPV. So therefore, do not proceed. Now, the second part says, what if they put in an option to abandon? 1 year from today, you find out you have the option to sell the machine for $250. So if it's successful, you wouldn't sell it because you would take the $575. But if it's a failure, you would sell it instead of an NPV of 0. So now the new NPV is going to be still the negative $300 that you pay for the machine, but you got a 50% chance of getting 575 if you're successful, and a 50% chance of getting 250 if it's a failure but you abandon it, and you divide it by 1.1 to the power of 1. So this becomes plus 113, plus 75. So now you would do it. So this option has made it worthwhile. And part C says, what's the value of this option? What's the value of the option to abandon? So this would be the new NPV. Now there's two ways to do this, minus the original NPV. Okay, so the new NPV is $75 positive. The original NPV was negative 38.64. So you get a value of 113.64. Okay, now this would be called the absolute value of the option. And this is what the textbook says. However, what's the relative value? The relative value is going to be the 75 minus 0, or $75. So why are we minusing 0? Because in this scenario, if it had turned out that we calculated an option or an NPV of negative 38, we wouldn't proceed. Okay, so you do not proceed, or you do not do project at NPV of negative 38, what was the number here? 38.64. Okay, so it's assuming we would have proceeded at 38.64 as a loss, and the 75 is the difference. But really what would have happened is we would have abandoned it. So that's another way of valuing this, and that's called the relative value, and that's probably more realistic.